How to write a GraphQL server? Well, first of all, let's start from a little bit of history. In 1999, we had REST. Roy Fielding, a PhD thesis, came up with an architectural style that was a big improvement over whatever we had before, like SOAP and that kind of stuff. So, big improvement. A lot of people liked it. We used it for a number of years. We still use it, and we're still going to be using it for a long time. In 2005, stuff started to happen around the fact that people started to realize that REST had some limitations. So, in particular, I found it interesting that Microsoft invented something that's called OData, something I didn't know myself, but I just learned that it was an attempt to try and solve what the limitations of REST. And it was nice in its own way. It's kind of weird if you look at it today comparing to what's available out there. But it's nice to put it in context. That's people started to look for better ways to do stuff. And then Facebook invented internally what later on became GraphQL. And it's been invented between 2010, 2012, depending on whom you ask to. But they started using it internally heavily. And then eventually, in September 2015, it was publicly released. This is not even 2 years ago. And already we have a huge adoption. We see a huge adoption. There have been two conferences about GraphQL, one in the US and one in Berlin, which I attended, and it was a really, really nice conference, the GraphQL conference. About 300 people, all excited about this new technology. Many, many people using it in production already, so it was all about discussing best practices and stuff like that. So it was really interesting. And so basically, we used REST for a long time. Then we realized that that could have been better. I started looking for a solution. Somebody finally had a good idea, started to build it, and now it's spreading really fast. So let me show you who's using GraphQL. Well, Facebook obviously, but also GitHub. So they used to have a public REST API. Now they don't have a REST API anymore. They have a public GraphQL API. So that's a big one, I think. Pinterest, Airbnb, Tesco, talking about big companies, Walmart, the New York Times, Coursera, Intuit, so you name it. If you go to graphql.com, you will see a huge list of other companies that use it. And this is just the monthly download rate of Apollo client, which is a GraphQL client library. And so the area of this graph is the actual number of people using it, and it is growing really, really fast. So let's start from REST. In order to understand GraphQL, let's see what REST looks like. And we know that REST has this URLs to represent some resource, some resource, and the URL means something according to some documentation or prior agreement. And then we fire this request to the server. We have an implementation that somehow calculates a JSON response value, and so this is how it works. And the implementation is kind of opaque in the sense that REST doesn't mandate anything about how you doesn't dictate anything about how you are supposed to implement the server. So it's only a contract between the shape of the URLs and the stuff you're going to get back as a JSON representation. And a complete system or an API is made of many entry points made with different URLs. And so the whole set of these URLs make up for your API. REST has some disadvantages though, because first of all, one specific entity is conceptually represented by one specific URL. And so if you have a user, you have one URL for that user, and that doesn't change if your requirements as a client are different. So if you're a web application, then you need a lot of information probably. But if you're on a mobile device, maybe you need less information. And in that case, you're gonna overfetch, meaning that you're still gonna hit the same entry point, and but you're gonna get a lot of information that you don't care about. So that's one problem. One way to mitigate that problem is maybe split those entry points. Maybe you have user and user brief or something like that, user short, something like that contains less information. But then you have a proliferation of entry points. And so this is not nice because of duplication, logic duplication, and also maybe implementation duplication. So it's not nice. Also, if you go by the book and implement RESTful architectures, then you may end up having too much network traffic, because first maybe you fetch the user, and then you fetch the sites for that user, and then the projects for that user, just to show up one page, maybe no UI. So these are the limitations of REST that GraphQL solves. Very briefly, because then I want to show you what GraphQL looks like, but GraphQL offers a way to formally describe your system with a type system. So you have an actual type system to describe your data, and basing on that, you can every request can be different, because you can ask exactly for what you want in the request. And so you get exactly that, and so you get predictable results. So these are the advantages. So as I mentioned before, GitHub has a new public GraphQL API, and so let's see what this looks like. So if we go to this to their site, we're gonna see this is their website, and let me make this bigger. And so they have in the center part of the screen, we see this tool that's called GraphiQL. This is a tool that's common to most GraphQL implementations, and it's just a simple wrapper around the fact that a GraphQL request is just a plain HTTP request, but it's just a nice dress around it that provides some extra features. So you start with a query, and the GraphQL schema is totally introspectable. So you know what you can query by just using the client like GraphiQL. And we're going to ask for a viewer. Again, viewer is something that's really common to every GraphQL implementation. So that's the only thing I know pretty much. The rest I'm coming up as I go, because I don't quite know the GitHub API. But I see that there's an email here. So if I fire this request, let's see what I get. Well, I get my email address. So this is me. I just logged in as myself, so this makes sense. They probably have ways to query the repositories. Yeah, there you go. So I want to see the first 10 repositories. Let me make this slightly smaller. It's going to be okay on the screen. And then, for each repository, well, first of all, before going into each repository, let's see what we can find. Well, total count, yeah, that's interesting. So let's see how many repositories I have. Oh, I have 36 repositories. And actually, I found it interesting that they show the total disk usage. So now I know that I'm occupying 75 megs of GitHub space. That's interesting. So let's filter by privacy public. So I have 25 public projects in my account. Now I can iterate over them. Forget about edges and node for a minute. This is just a way to iterate over a collection in GraphQL, and they're probably going to have a name. Yeah, there you go. I have a name. So yeah, these are the first 10 public repositories in my account. And so if I want to see the next 10, what I can do is show on the edge, show the cursor, and it gives me an opaque string that I can simply copy. Doesn't mean anything to me, but it means something to the server. And so I can say, give me the first 10 repositories after this one. So this is how I do pagination, because now I have the next 10. And so yeah, this is how you do pagination, and this is what GraphQL looks like. You see, it's very simple. You specify something that looks like a JSON without the values, and then you get back a JSON with the value. So and then you have embedded documentation. So if you go here, you'll see a documentation of what we just did. So this is all stuff that comes for free in a way, because it's embedded in the way you describe the system to begin with. So it's I think this beats the hell out of all the tools that are available out there for REST, for documentation, because it's still separate. The implementation is separate from the documentation. In GraphQL, it's the same. It's in the same place, so it's much easier to maintain. So let's go back to the slides. Let me tell you why it's called GraphQL. So we have, as an example, we're querying a user, and then the sites for that user, and then the projects that belong to those sites. And then maybe in our example, maybe we have the concept of users that collaborate on that project. So why not ask for them? So yeah, if we do that, we see that this is not a tree anymore. These boxes over here to the left, they look more like a graph. In fact, because I'm getting a user, it's the same type as a user is a user, so I can always ask for the sites of those users. So why not even complicate even further the query? So you see, basically what I have on the left is just a graph of my model, the model of my API, the conceptual objects that I want to expose through my API, and GraphQL is simply a query language for that graph. So it's it's like SQL for the web in a way. So you have a model that represents your API entities, and then GraphQL is a way to query it. And because it's a graph in the most generic sense, then when you query a graph and you visit a graph, you get a tree out of it, and that's your JSON. So that's why it's called GraphQL. And actually, that explains why that explains that edges and node terminology, because the edges are the arrows and the nodes are the boxes. And so that's a generic way to, it's not part of the GraphQL specification, but most implementations decide to use it because it's compatible with Relay. Anyway, let's see how GraphQL works and how you implement it internally. So if that is on the left is our query, the way that we implement a server is by using a concept of resolvers. A resolver is a function that basically returns information that can be introspected. So for example, in this case, I must have a user resolver, because that's the function that ultimately returns something that contains the first name, the last name, the email, whatever have you. So I gotta have a function that's being called for the user. And then because this user has several sites, I'm gonna have to have a site resolver as well, which is gonna be called once for each site. And because we also have projects belonging to the sites, then we also need to have project resolvers, which are going to be called once for each project. And then in this example, we also have a user resolver being called again. So this is how it works. And if you compare this, and each one of these results, these resolvers returns something that is ultimately used to create the JSON response. So if you compare this with the black box of REST, you see already that the GraphQL specification is much more, REST was an architectural style. So it wasn't, it was definitely not telling you how to implement your server. It was just telling you what the server should behave from the external point of view. GraphQL is still a specification. It's not a library on its own. There are several libraries in several languages that implement GraphQL, but it's ultimately a specification. But it's a specification that goes into much more details about how to implement your server. Specifically, it mandates the existence of these resolvers, resolver functions. And so this is how it works. And when you see this, you may think, oh my God, I have the N+1 problem. That is, I'm calling these functions way too often, like a bad ORM, right? You end up hitting the database. If each one of those resolvers needs to hit the database, for example, I'm going to hit the database every time for every entity in my model, and so this is going to be too inefficient. The complexity is basically linear in the size of the response, which is not very nice. So just to assure you, this is the very first concern that everyone approaching GraphQL for the first time raises, and there is a solution to that. We'll see that in a minute. So, but first, let me show you how to write actual code for for GraphQL. We're going to be using this Launchpad tool, which is really cool. It was announced in Berlin at the GraphQL conference. And we're going to be working on an exercise that makes use of words, which we're going to represent as a simple dictionary with the key text. And then words are made of characters, and we're going to represent a character with a dictionary with a key value. And so let me click over here and show you what a Launchpad looks like. So first of all, you have a screen that's split in half. On the right hand side, you will recognize GraphiQL, and it's working. So you can query your server. And on the left hand side, you have the server implementation. So this is a beautiful tool because it runs in your browser, but what you're writing here is node.js code actually running on a node.js instance in the cloud. So and executing in real time. If I change this hello world, it's going to update the right hand side in real time and allow me to query again and see the updated result. See, so this is really cool. When you start for the first time, you're gonna have, like I just did, you're gonna have a lot of comments over here that explain you how to get started, and then you're gonna have a bunch of boilerplate down here, like make executable schema. You don't need to understand this right now. What you need to understand is this. So basically, up here we have the type definitions. This is a string. It's a language defined by the GraphQL specification. And now here you have the resolvers, the functions we just talked about. So let's make an example. So type query is something that you need to have. That's, you know, the root type, you have to have it. In our example, we're going to have, we can make something that called word. That returns a word. And but to make our example simpler, let's just pass the content of the word as a mandatory string. So string with an exclamation mark means that it's mandatory. Then we need to define the type word. So word is a type that has a property that's called text that returns as the string. Yeah, that's my name. String. So this is already a good start. So let's implement the resolver. So if you look at a resolver, this is how it should look like. So if you think about Java, this is a function prototype. So you're telling the system that there's going to be a function called, it's going to be a function in the class query. This is the class. This is the method. These are the parameters to the method, and then this is the type of the return value. So this is what it looks like, and this is the implementation. So this is the method again, and these are the parameters. This is self. This, depending on the language you're used to, you know, it's the instance, a reference to the actual instance. And context is so args are the arguments up here, just collected in the dictionary. And context is something you can provide down here at the bottom, something that's available to every resolver. So you can put like your database pool there, for example, if you want to access the database or anything else you need. So this is how it works. So let's make the resolver for word. And we said the return value is supposed to be word, and we just decided that the format is going to be a dictionary with text in it, and which is going to contain args content. So this is how we return our word from this resolver, and then we need to implement the resolvers for the type word, and we're going to have one resolver text, which is going to take a word and it's going to return a string. So word that text. So this is our resolver, and it should be already working. So we see that the schema is already introspectable. We have word here, and so system already knows that it takes a parameter content, and then when we foo, and then we can ask for the text. And if we run this, there we go. We have our word. So now with the word we can do, for example, ask for the characters, which is going to be a list of character. So a list, the type list is defined by the square brackets. And so now we need to define the type character. And the type character is going to have again, a text of type string. And so there we go. Let's implement the characters resolver that takes a word and it's going to return a list. Word of text dot split. We're going to make a list of characters. We're going to create a new list based on the old one, where each element is going to be a dictionary with value equals the char. This is what we defined was the we decided was the representation of for a character. And then we need to define the resolvers for the type character. We're only going to have one, which takes a character and returns, we said it returns a string, that is the value, character.value. So this is how it works. And let's see. So we can have characters, yes, and for each one of those characters we're going to ask for the text. And there we go. Now we have our foo. And this is, and then we can play with this. You know, like for example, for a character we can ask like a sample word. Why not? A word that starts with that character, and then we can implement this resolver over here in the character type that, given a character, returns a word. So it's going to be something like this. And let's say if character dot value equals f, then for example we can return a word like fantastic. Otherwise, well, we'll just return null, which is perfectly fine because we don't know other words, so that's fine. And if we run this sample word and we're going to ask for the text, yeah, we get fantastic. Now let's imagine that, for example, instead of returning we have an error, so we throw a new error, foo. Now this is going, you see, this is not going to break. We're still going to get our response nice and clear, but with the sample word that's the one that breaks, we're going to get a null instead. But also, in addition to that, we're going to get another result, another information that's called errors. It's a list of all the errors that happened. And so this is a nice way to gracefully degrade in the case of errors. Of course, you don't want to have this in production, you know, in the end, but it's nice for development. It's not going to totally break your code if you have exceptions. So this is how it works, and you can see how this is really flexible. The nice thing about this tool, Launchpad, is that you can actually download what we just did, and it was going to bundle it up as a zip file that you can unzip in your system, and then it's going to be a node.js application. You just npm install, and you can run it already. So what a nice way to get started. Let's go back to the slides. So let's see what we just did. This is what we, on the left hand side, you see what we did. So basically we typed the definitions with this language, type definition language, and then we implemented the resolvers. If you've noticed in the boilerplate, there was a function that was called make executable schema. That was basically taking the type definitions, adding them to the resolvers, and then making up something that looks like the stuff on the right. So you can still programmatically define your schema, and you can actually choose which style you want to use, and you can generate the other side. So it's really a choice that's up to you if you're working in JavaScript. If you work in other languages, your choice may be reduced to maybe one of these two styles only, but they really are equivalent. It's just a different way to specify, and maybe you'll find one nicer than the other depending on your situation. So let's now talk about the N+1 problem, how to solve it. You ultimately solve it in different ways depending on your language and depending on the actual implementation of your REST of your GraphQL server. But I think the way that's been solved in JavaScript is pretty interesting and it's worth discussing a little bit. Um, First of all, what is the N+1 problem? Well, we said, you have a user and you need to select the sites for that user, and so that's a query to the database that comes back with, let's say, 3 sites. Then for each one of these sites, you have to fire a request, another request to the database to find the projects. And so you get a bunch of projects for site 1, another request, a bunch of projects for site 2, another query, and so on and so forth. So you see that this is one query, and these are n queries. So that's why it's called N+1 problem. It's a problem because you don't want to go to the database so often, so many times. So how do you solve it? Well, let's go to the code now for a minute to see how it's been solved in JavaScript. So let's say we have a calculation that takes a value and returns some computed value, and we have a function that calls that calculation given a parameter. And then we have, we call a couple of times and we print out the result. This, the output will be 2 and 4, of course. Now, let's say that we want to make now the f function asynchronous by introducing a promise. So this is how we need to do it. So we're going to create a new promise, and then we're going to call the complex calculation and then resolve the promise. And of course, the way we do the console log is different because we have to use then. The output is still going to be the same, 2 and 4. Now, the bigger step is the following. So let's say we want to add a way to, so a promise is a way to defer the calculation of something at an arbitrary point in the future. So this is nice because it allows us, if we want to collect the parameters to those functions and call them at a later time, and call the complex calculation at a later time. So let's say that we want to do that. And let's introduce at line 1 an array of collected calls. And then at line 17, instead of calling calculation right away, we just push to that array the parameter together with the result function. And then we're going to call at 19 a process hold pending function, defined at 7, that's simply printing the number of values that have been collected and then going through each one of them, call the complex calculation, and then resolve the promise. And of course, clear up the array. So if we do that, we're still going to have complex calculation called twice and also process hold pending called twice, right? But every time we call it, we're only going to find one value in the array because we're pushing a value, processing the array, calling the calculation on that value, and then clearing the array, and then do it again for the second time. So far so good, and not very useful, to be honest. But now there's the last step, which is the critical one. We're going to introduce this little call. It's called process next tick. So this is a way in Node.js to say that this function is going to needs to be called later on when the event loop comes back after it's done with whatever it's doing right now. So if we do this, we're basically going to have those two parameters pushed into the collected calls array before, both of them pushed, before the actual first process hold pending call happens. We're still going to call process hold pending twice, but we're going to call them after we've collected all the parameters. So the output is going to look like this. So the first time we call process hold pending, we're going to find 2 values. And the second time, of course, is going to be empty because we've emptied it and nothing, no one else has added more values. The output result is still going to be 2, 4, so we haven't changed the semantics of this code, but we have introduced some delay, some logical delay. This is not going to be slower in executing. It's only going to be processing things in a slightly different order so that we now have the opportunity to know all the collected parameters when we are about to calculate to call the complex calculation. So in this case, the complex calculation is not very complex, but in real life, we probably want to go to the database or somewhere as expensive, if not more. So if we need to go and fetch the site for site, fetch site 1. I mean ID 3, and then fetch site ID 10, and then fetch site ID 24. This is bad because we go to the database 3 times. Wouldn't it be better to go to the database only once and leverage the in operator That's much more efficient because we can leverage an index and scan the table only once. And this is exactly what this trick allows us to do. It allows us to know all of the accumulated parameters and allows us to fire a request to the database in a much smarter way. So this is called batching, and the library that implements this trick is called data loader. And in real life, you don't have to write code just like I showed you before, but the library takes care of this for you. But you have to understand what's going on under the hood, otherwise it seems like too much magic. In reality, it's not magic at all. It's just leveraging the fact that Node.js is asynchronous and there's an event loop that allows you to do batching in a smart way. So now, if we look at the N+1 problem, it's solved because we get the sites from the user with one request, just like before. But now we know all the IDs of those sites, and so we can go to the database only once to get all the projects we need with all the IDs of the site. And of course, we have to do this in a smart way, so that out of that big list of projects, we know which ones belong to site 1, which one belongs to sites 2, and so forth. But now this is one query, and this is one query, and basically we've reduced the complexity of the implementation from, roughly speaking, very roughly speaking, from an order of n to an order of log n. So basically, instead of going to the database once for each entity in our response, we'll go to the database once for each level of the tree, which is much better order of complexity. So this is it, and I basically talked about how to write GraphQL on the server, how to implement GraphQL on the server. A totally different talk would be to how to use GraphQL on the client. Because on the client, you might as well, as I said, GraphQL query is just a regular HTTP request, so you might as well just go ahead and do however you do with Ajax, with REST, by using an Ajax call and fire an HTTP request that way. And that's actually a nice way to get started and migrate maybe an existing legacy system from REST to GraphQL. But after a while, you soon realize that it's nice to use what's called a client library. So Apollo and Relay are two GraphQL client libraries, and those are JavaScript libraries that take care of advanced stuff like caching on the client side, building the query for you in such a way that you can describe the data requirements in a very nice and compact way, really close to the UI components. So it's really cool. Eventually, you want to look into that, definitely. Data loader is the library that I just explained, the internals, to solve the N+1 problem. So here's a little extra information basing on the questions that I normally get after this talk. One important chapter that I was about to forget to talk about is authentication and authorization. Here's how it works. So you have your HTTP requests that comes into your system. You're still going to need a regular entry point controller in your framework, in your server, to deal with the /GraphQL entry point. You're not going to have as many entry points as a regular REST API, but you're still going to need at least GraphQL entry point. And so in this controller, you do a lot of things. Most importantly, you do authentication. So you know your user profile. And basing on that, you can take important decisions like, for example, global authorization. For example, you can decide that a given user profile, a given type of user doesn't have access to /GraphQL at all. And so you can already deny that with a 404 or something like that. And then you can also do a schema choice. For example, this is a nice way to differentiate regular users from administrator users. They can be served different schemas altogether so that regular users don't even see what an administrator can do because they have a different schema. And then, most importantly, this entry point controller is responsible for creating the context of the actual resolvers. So the context is then passed to the schema resolvers. And the context really is just a box where you can put everything that's relevant to your resolvers. But definitely you want to have your user profile so that resolvers know how to take decisions based on that. And then you can put definitely your connection pool to your database. So your resolvers can query data from the database or handles to your external services. So again, for resolvers to do their job. And then finally, the resolvers finally kick in. And in each resolver, you can take advantage of the information you have in the context. And so, for example, you can do fine-grained authorization. So you can decide that a given user doesn't have access to a specific attribute. And so you're still going to see that that attribute is available there, but it's going to get a null. And then if the user instead is authorized, then you can actually perform the execution of that attribute resolver. And so this is how you deal with authentication and authorization. You have two different levels, more granular, fine grain, and more coarse granularity. So the other topic is, the other thing is that, a slide I should have shown earlier on. So basically what I've talked about in this topic is how to query your data, how to read it. But I didn't tell you how to write your data to the server, and that's mutations. Mutations are basically, they're not really complicated. Think of it as just a remote procedure call. So you just have a remote method that's given a name and a set of parameters. And that's it. You basically fire that method remotely. But when you do, you have the choice of, you have the opportunity to specify a query using the same formalism that I just showed you. Basically you can ask the server to send you updated information as soon as that mutation is happened. So in an atomic way, you can perform a data changing operation, something that has side effect, and at the same time receive the updated information that action has affected. So that's how mutations work. And then finally, the most exciting piece, because it's the last addition to the spec, is subscriptions. So by leveraging a push mechanism like WebSockets, you can have your server emit events. And so your client can subscribe to these events. So events are just things that have a name, and your client just subscribes to those events to get notifications that those events happened. But when you do subscribe, you have, again, the choice of specifying a query so that not only the server tells you that that event happened, but it also tells you, it gives you updated information that you know that event might have impacted. So that's how it works. So thanks